Hello and welcome to this new lesson, in which we will talk about analog to digital conversion. In this lesson, I will explain how to connect a potentiometer to an Arduino. The requirements are computer or a laptop, Arduino microcontroller, USB to serial adapter if your microcontroller does not have a USB port, appropriate USB cable, potentiometer, built-in LED. These are the types of potentiometer. The circuit of this lesson should look like this. Connect the potentiometer to pins A0, 5 volt and ground. The middle lead is the one to connect to the analog pin, and the voltage varies on this pin. The orientation of the other two pins does not matter. Now, I will show you and explain to you every line of the code, which is required to proceed this lesson. We will start by initializing the variables as before. First, int sensor pin equals E0 semicolon. The name sensor pin was chosen only to describe what variable represents. The integer sensor pin is equal to A0, where A0 is analog pin 0 on the Arduino. On its own, A0 is not a reserved term. However, when used in context, the system recognizes it as analog pin 0. The line must end with a semicolon, like I said before. By declaring a variable in the setup, you can use the term, which in this case is sensor pin, throughout the code instead of A0. There are two main benefits to this. 1. It makes the code more descriptive. 2. If you want to change the value of the variable, you only need to do it in one place. Then, int sensor value equals 0 semicolon. The term sensor value is not a reserved term either. Then, int LED equals 13 semicolon. Once again, the term LED pin is not a reserved word in Arduino. It was chosen to describe which pin was connected to the LED. The value 13 is a normal value, but just like A0, when used in context, represents pin 13. However, you will need to add the following code under the void setup. Pin mod LED pin output, which is used to declare that the LED as an output. At last, we write the void loop, which will be repeated indefinitely. Sensor value equals analog read sensor pin semicolon. This line uses the term analog read in order to read the voltage of an analog pin. Most microcontrollers use 10-bit analog to digital conversion, in which voltage to numeric conversion, which is 2 to the 10th power. Possible number equals 1024. Therefore, a voltage of 0 corresponds to a numeric value of 0. A voltage of 5 corresponds to a numeric value of 1024. Therefore, a value of 3 volts would correspond to a numeric value which can be calculated like this. I wrote the equation. You can get the answer doing this. 3 divided by 5 equals x divided by 1024. We put the x on one side, so we write 3 multiplied by 1024 all divided by 5. The answer will be approximately 614. Then we write digital write LED pin high, which turns the LED pin on. Delay. The delay should take the delay time from sensor value, which stops the program for a milliseconds of the sensor value. Then digital write LED pin low, which turns the LED pin off. The delay, again taken from sensor value, it stops the program for a millisecond of the sensor value, as I said. Once the potentiometer is connected, upload this sketch to the board and change to the serial monitor. As you rotate the knob or slide the slider, the value should change between 0 to 1023. Correspondingly, the LED will blink with a faster or shorter delay. You can now read the values and use them with your code. The new function used here is analog read, where the pin is selected is pin number 0. If you used analog pin number 5, you should change the code to read int sensor pin 5. If the system does not work, check the syntax and ensure the code uploads correctly. Next, check the connections to the potentiometer, ensuring that the middle lead goes to the correct pin, and the other pin are powered at 0 volt and 5 volt. If you bought a very cheap or old potentiometer, there is a chance it may be mechanically defective. You can test this using a multimeter and connect the ends to the middle pin and an outer pin. Set the multimeter to read resistance and rotate the knob. If the resistance changes slowly, the bot is working. If the resistance is erratic, you need a new potentiometer. Now, what if you want to see the value yourself? Take a look at the code that I'll display here in the Arduino interface as a new sketch. Like before, initialize the variable int sensor pin equals 0, which selects the input pin for the potentiometer. Then int sensor value equals 0, which is the variable to store the value coming from the sensor. But some new functions will be used now under the void loop and the void setup. Under the void setup, we write serial.begin in between brackets 9600 semicolon, which initialize the serial communication at a baud rate of 9600. Then, under the void loop, we write serial.println in between brackets sensor value, then the semicolon. This sends the value contained in the variable sensor value serially via the USB plug and digital pin 1. Verify then and upload the sketch to your Arduino. Once it's done, press on the magnifying glass located towards the top right of the window. This is serial monitor, and monitor's communications begins sending and receiving by the Arduino. Here, you must verify the baud rate is also 9600, or else you will see garbage. Thanks for watching this lesson. If you have any question, please ask it in the Q&A board. See you next lesson.